Thanks, Matthew. So hi, everybody. My name is Ian Molloy. I'm the Senior Product Line Manager for MEP and Building Performance Analysis at Autodesk. So it's really great to talk to you all here today. I actually have a couple of connections with Manchester. One is actually my grandmother on my father's side is actually from Stockport, just outside Manchester. That's a funny coincidence. And actually as well, a different Manchester, New Hampshire, is actually where a lot of Revit is based. I'm actually based in Boston, Massachusetts, which is where the AEC headquarters are. But there's an office about an hour north of that. A lot of Revit development happens there and in Boston, as well as in China, in Shanghai. And it was great to talk to everyone here today. Thanks, Matthew, for inviting me. I noticed in the poll, there was one sole lonely MEP engineer in the list, a couple of BIM managers, and then like a lot of architects. But I think, Matthew, you said earlier on is that this is increasingly the area of building energy use and carbon emissions and things like that is an area of increasing interest with architects. There's been a number of different initiatives. I know the UK has its own special one. There was one like the AA 2030 commitment, basically a call to action to try to, lead more clients to more sustainable designs and better energy efficiency. Of course, you've got things like Part L of the building regulations in the UK, which is like what I call it, like a compliance workflow. It's like a documentation workflow. Those things don't really help with design, so to speak, particularly early on. So what I'm going to do here today, this is a sort of a big area of subject matter. And what I'd really like to do is just to give you a sense of the tools that are available to you in Revit, or maybe to your peers, or maybe some of the engineers that you work with. And then even just yourself, you could just give you enough knowledge to know what they do, and maybe you can have a play with them yourself. I'll show you some very simple things. You can just have a play around with it and understand what they do. You'll also kind of get a sense of where we're going. As a product manager, what that means is I work on setting the overall sort of strategy for product development, as well as working with the development teams on a daily basis. My background is actually in mechanical engineering, what we call building services in the UK, right? I've become so Americanized, I use the term mechanical engineering, but it's building services. It's a relief to kind of say that for a change. So yeah, so I'm gonna go through a deck here that sort of gives you set the level about all the tools that are available and how they work, and how they were developed over time. So a little bit of history as well. And if we have time, I'll show you some really simple examples, just enough for you to kind of have a little bit of a play with it yourself. And hopefully that will sort of start you off on the learning curve and pique your interest a little bit. So let's get going from there. So there's really three tools, really. One tool, two parts to it that I'm going to be talking about today. So there's obviously Revit is at the center of it. And when it comes to building energy and systems analysis, there's a tool called Insight, which is kind of its own brand, but it really is just a feature within Revit that's available to any Revit or AEC collection subscription. You get access to Insight. And there's a few parts to Insight. I'm going to be talking about the energy piece today. And then systems analysis is a feature that we added late last year in the 2020.1 update. It was actually arguably one of the biggest features in sort of size that we've ever added in a point release. That's just a sort of a bit of trivia, but it's significant insofar as what it does really for the gap that it fills in the overall MEP workflow, particularly connecting design to sort of 3D modeling and documentation and coordination. You'll sort of see where that fits in. Now, I've got limited time here today, but if you want to take a screenshot of this, if you want to find out more about any of these, I've done a number of webinars in the past, and there's some recordings on sort of like everything you want to know about Insight, from how it gets installed and how to run it to what it actually does and what it's intended to do. And then through to systems analysis, I did there's a couple of classes at Autodesk University last year that if you want to pass these on to your MEP engineers to take a look at, this really, these features can do a huge amount. I mean, it's more than just a feature, right? And I mean, like, for example, compared to, for example, a feature like zoom in schedules or import PDF, there's a little bit to know about that, but not a huge amount. There's a lot to know about this. So there's a sort of a fairly, I won't say it's a fairly steep learning curve, but there's a long learning curve. And what I recommend in that class is a really good way to get started, because there's, a lot of people either know Revit but don't know energy analysis, or vice versa. So this is a way to kind of bring both of them together, so that to start to do more of this type of analysis work early in the process directly from your Revit model. So there's some references there for you to take a look at in more detail. So the background to all of this is that, there's actually a website called buildingenergysoftwaretools.com. We're actually a sponsor of it. That's why our logo is in the bottom left. And it lists internationally over 200 separate tools that do energy analysis, building energy analysis and systems analysis in a variety of forms. And they all have their different strengths and weaknesses, different purposes, different scope and things like that, different ease of use or complexity and things like that. But one of the things they all kind of lack is that none of them have really become sort of de facto standard in terms of a standard care of practice on every project or a common language that everybody speaks. Every single one of them has got a different data model, different input, different geometry, different set of assumptions, different engine, you name it. So it creates a lot of kind of, people don't know where to get started, what the right tool for the job is. And of course, at Autodesk, we try to take a kind of a platform view. What is the sort of like the simplest things that everybody needs to sort of start to do more of this, as part of every project, particularly early on. A lot of these tools, I'm not going to bash any of them. There's a lot of really great tools in here, but a lot of them really rely on sort of very late in the design process, very detailed sort of tools. They don't really work well early in the process, and they're very engineering-y or specialist orientated. So what we're trying to do is level the playing field for everybody, from the model creation side of things to actually what assumptions do you make, what analysis do you run, what sort of comparisons do you make, and things like that. So we've been at this quite a long time, actually. If anyone, depending on to show your age here, but like the very first kind of feature that we added in Revit to support this kind of thing was around GBXML export. And if you've ever used that, your experience will not have been good. I've been there myself before I was at Autodesk, and there's your mileage will vary widely. But we've been learning a lot since then about how to really connect design to analysis, and there's a lot more to it than you think. So we've been obviously working with customers to sort of study the space and understand what the blockers are. And this is just some of the really key ones that we come across, is that for the most part, you talk to people, particularly architects, it's something that they're interested in. They all talk about sustainability and better built environment and things like that, but they have real difficulty actually doing anything about it, because you don't get paid for it, and it potentially introduces some risk on the project, and it requires sort of special tools and expertise that can be kind of costly. And then as you get deeper into it, it generally requires a completely separate model. You need to create it and then keep it up to date. A big one is, you've all heard of the garbage in, garbage out kind of concern. How do you know that you can trust the results? If you're going to base a design decision on something, how do you know that that's accurate? And then also, like I said, a lot of these tools are applicable late in the design process. Like, for example, Part L compliance is very much a documentation exercise, right? It's not really a design exercise. So there's a real gap early in the process to make sort of better decisions early on. So people have been saying this 15 years ago, and they're still saying it today. And we've been trying, these are the set of problems we've been trying to solve. And the strategy that we took to it is not just to sort of create another tool to add to that pile of 200 tools, but to really try and solve the deeper set of problems that are there. And I won't bore you with the details, but like I said, it's a very long journey along the way. We've done a number of different things like GBXML export, heating and cooling load calculations. Some of you might remember tools like Vasari. Obviously we had Ecotect, and we acquired that and we killed it off. We've done a variety of ways to create an energy model. And one of the things you see is that there's still a lot of that legacy stuff in there, and it creates a little bit of confusion. I'll try to help you navigate through that. And then about 4 years ago, we kind of rationalized a lot of that, especially what was in Vasari, and sort of rebranded it and launched it as Insight. And then last year, we launched Systems Analysis, which you can kind of think about as Insight is the big picture kind of telescope view, and Systems Analysis is the very, very detailed sort of microscopic view. But throughout the whole thing, we've tried to make this stuff as easy and as fast as possible, yet also to be as accurate and reliable as possible. And really, the term scalability and cohesion really mean about the ability for multiple people to be able to do the analysis, not just engineers, but also architects. Give them a common language and data model to be able to use, as well as be able to span through the different design stages. Start early and do your analysis often, and move into the design, detailed design, rather than wait until detailed design to do any analysis, right? So I'll just keep moving here. So the key to it, the very first piece to this is the creation of what we call an energy analytical model. That's a very Revit-y term. And it's because some of you probably know there is in Revit a structural analytical model. So to be consistent with that, other people would call it an energy model geometry. They might call it zoning or something like that. But the point is, a Revit architecture model is essentially anything from a series of conceptual masses to, detailed building elements, walls, roofs, floors, windows. And as you guys know, I mean, just because it looks like a building doesn't mean that Revit knows it's actually a building, right? It's a series of walls, floors, and roofs, all parametrically connected. But what an energy model ultimately needs is, volumetric understanding of the building, kind of similar to what the last presenter was just talking about in terms of, what's the volume of air in each of these spaces, and then that provides the ability for them to calculate the amount of heat transfer that occurs through the building, right? So the creation of an energy model has always been sort of shrouded in mystery with energy modelers, but it's really not that complicated, right? You need to basically identify volume inside the building and the paths of heat transfer. And we've got a number of methods that completely automate that. And that's a little exercise I'm going to show you towards the end if I have time, right? We built this to try and be as robust and reliable as possible in terms of, again, you guys will know Revit models vary in sort of modeling style and practice almost infinitely, right? No two Revit models are the same, or no two practices develop their Revit models the same way. You'll have all kinds of little maybe gaps and overlaps in the physical model that are fine for rendering and programming and schedules and things like that. But then you do any sort of Boolean operation to extract analytical geometry has traditionally caused problems. So we created essentially a number of ways to extract that at different levels of detail with very high tolerance for how that works. And to really get the most of that, you just need to understand, what you're feeding into the model and what you're trying to produce from that. I'm going to walk you through that later on. So then once you have that model, then that allows you to run Insight, right? And what Insight provides uniquely is a building energy range. Most traditional energy analysis provide you with a single point estimate, like your total building energy use intensity will be X, and here's how it breaks down. And if you want to go and see what the sensitivity to things are, is you've got to go in and sort of vary the wall properties or vary the orientation or vary the mechanical systems, run another analysis, do an A/B comparison, and manage all that yourself. But what Insight does is it sort of automates and manages all that optioneering for you. And really the things that it does and doesn't do is that it uses the same model as you're using for Revit. Instead of it, we describe it as analysis. We tend to provide it more as guidance, because if I tell you the building energy is 1, 2, 3, well, is that good? Is that bad? What will make it better? So Insight, because it analyzes a number of options, you can more clearly understand the factors that are really important in the building and how accurate your model is. It spans concept to detail, and it's really intended to be collaborative. I mean, this is primarily aimed at architects at early conceptual schematic stages, but it's just as applicable for an engineer to use to have a conversation with an architect about, why they maybe don't want too much glazing on the south facade, or if you're going to have a lot of glazing, you can at least make it a high performance type of glazing to sort of reduce energy and loads in the building. But the thing that it's not doing, that people often sort of, expect it to, but it clearly doesn't, is what we call the detailed design and engineering and design analysis, the sort of traditional form. It's using the same engines that a lot of those tools do. It's just not allowing you, Insight at least, the very fine, precise control over the inputs. It's still very accurate, but it's not bogging you down in kind of the fan performance curves or the convection coefficients or the coil bypass factors and all these hundreds of millions of obscure inputs that all have an impact, but only really matter if you're interested in that particular aspect of performance. In overall building energy terms, Insight sort of covers the major landscape of things, and we'll take a look at that. So that's what Insight does. And what systems analysis does is systems analysis provides that final piece of that jigsaw, right? In terms of systems analysis allows you, particularly for the systems side of things, the ability to define at a kind of schematic level without needing to model ductwork and pipework and actual equipment in the physical model. Very simply to basically just mark up what regions of the building are served by what type of equipment. So for example, you got VAV or fan coils or underfloor air or whatever it might be, and served by different air handlers and boilers. Whatever your zoning strategy is, it basically provides a very simple way for the engineer to mark up the building, associate equipment and plant with those regions of the building, and then run a single point systems analysis, right? So between those two tools, you kind of have the big picture overall direction for early conceptual schematic stages, and you have the detailed analysis tool. And the really key thing to be aware of with the systems analysis tool is that we've learned from our sort of mistakes in the past, excuse me, that any analysis tool that we provide, no matter what form we provide it, no matter how much we research it, somebody somewhere, some engineer somewhere is going to sort of take issue with the way we did a particular part of it, or they'll want sort of more transparency on how the thing is run. So the key thing to understand about what we've done with systems analysis is that it's built using these components called Energy Plus and Open Studio. Energy Plus is the engine. These are both US based. They come from the Department of Energy, but they're used globally. They're used all over the world because it's just building physics. But the key part of it is that it's open and extensible. All of the code that is used to run this analysis is all installed with Revit, and you can open it up and you can read it. It requires a degree of expertise to read that, and you can change it yourself. So you can kind of think of the analogy of just the same way you can create a script with Dynamo Player to run a certain execution on a Revit model. This is like that. It's specifically a language and a platform for doing whole building energy and indoor environmental analysis around things like temperatures and loads and things like that. So just stop there just to say, does that sort of make sense in terms of an overview of everything? Any questions? Well, I see there's some questions coming in. Some of these Ladybug guys, yeah, we know them. Sorry, there's a question there?
Yeah, we've got a question from the Aussie BIM Guru. So if Gavin, if you want to ask your question, please.
Yeah, I was just curious, I guess, how much interaction you have with the Ladybug Tools team, because I guess like you work with some very similar open source modules, and I imagine there must be some room for collaboration there, especially given that Rhino Inside is now given access to, say, Grasshopper into Revit as well. There's an ecosystem that might have some collaboration there, I think.
Yeah, so we know Mustafa pretty well. You know, the Ladybug, obviously, and those tools approach analysis from a certain perspective, and they really require two skill sets. One is you need to understand building science and you need to know computational design. We're trying to make things a bit more accessible than that. And traditionally, we haven't approached this in an open way, but we've learned we really have to. But you're absolutely right. Anyone who is capable of those kinds of things should be able to leverage a lot of value. In other words, they have a much richer tool set within Revit and the APIs to be able to drive new workflows on top of. So we haven't been working too closely with them recently, but that's going to continue to evolve over time.
Yeah, no problems. Yeah, thanks.
So I'm going to jump into the software pretty soon and just show you, but I think a couple of people have, just from talking to people over time, some people have some kind of conceptual barriers as to what this stuff actually is. And I like to kind of show this one here around what the systems analysis piece really is, right? And if you think about it, like what Revit is purely it's a physical modeler. That might sound obvious, right? But you're modeling physical stuff in XYZ space, and it's used for, you know, documentation, coordination, and detailing. And, you know, if you look at what's on the left or on the right, you'd say, well, it's a building or it's a system. But in fact, it's really neither of those things unless you embed the sort of information in the model that gives it the behaviors that you want. And I mean behaviors beyond two walls join and a roof join, or a duct and a pipe or whatever, and the flow rate between them. In other words, that thing on the right might look like a system, but it's not really a system unless you connect it all up and add in all the parameters, which, you know, is fine later in the process. But early on in the process, where you're deciding between two fundamentally different systems, which would have wildly different layouts, you need to do this analysis. And so what systems analysis basically allows you to do is, first of all, understand the sort of the volumetric sides of the building and the sort of surface area side of the building, so you can calculate heat losses and gains, and establish basically the overall schematic for the primary equipment that's going to go into the building. So things like air handlers, boilers, chillers, fans, pumps, zone equipment. And then critically, if you've ever looked at any MEP drawing, you'll see some weird reference on it, like AHU1 North XYZ, right? All of that is all inherited from the overall system strategy. So what systems analysis allows you to do is to sort of define that system strategy early on in the process. It kind of, I won't say replaces it entirely, but it sort of tries to replace and create a BIM-based form of what people normally do with a sort of a schematic, where they'll show something like a quasi 2D drawing of, you know, chiller up on the roof and 10 levels and an air handler in each level, and each air handler feeding a fan coil unit or something like that, or a VAV box. This replaces that because it basically allows you to see what regions of the building are served by what equipment. And then the analysis sizes that equipment. And that's ultimately what defines the flow rate through the equipment. So what we're trying to do is give Revit the ability to understand a parametric system, not just parametric parts, right? And that's always been a missing thing in the way Revit works. And even Revit's systems existing sort of work backwards. They sort of start with the equipment and the zone, and they work backwards. When in reality, engineers think about them in the other direction. So they're the kind of two ends of the spectrum that we'll be talking about in terms of there's insight and then there's systems analysis. I didn't notice what time I started at there, Matthew. How am I doing for time?
Hello, Ian. Yeah, we've got about say 20 minutes.
20. Okay, great. Just want to
ask questions.
Yeah, no problem. Okay, so where are we at now? Yeah, so I'm going to show you initially just what Insight does. So first of all, model creation, I'm going to show you this as a pre-recorded thing just because it's just faster for time. Model creation, there's a variety of ways you can do it. As you said, like, you know, with Revit, there's a variety of ways you can set your project up and so on. But what a lot of people find is even if you're at a conceptual stage, you can still have some relatively detailed Revit model geometry, right? And so you can absolutely translate everything in your architectural model into an energy analytical model. But guess what you'll get? You'll get a very, very detailed, very large analytical model that won't necessarily improve the accuracy of the analysis, right? So when you're learning, and especially early on, we always recommend, you should start simple, walk before you run. And so the easiest thing to do is to work with the conceptual massing environment and essentially build a kind of a shadow model of the building. So this is just one way. It's not the only way to work. It's just a good way to kind of learn. And so all this little video does is show how easy that can be, where you start sorry, I'm after skipping one forward. Start essentially you can create a Revit template. I have one available in the AU class, and it's metric, by the way. Start a new template that has a lot of data in it for systems analysis. Import your Revit link. The important thing is just set the link to be non-room bounding. I'm using Copy Monitor here to just bring over the grids. You guys know this, right? This is all table stakes stuff, right? But the thing is, my model on the right now is that now I can use the model on the left as a sort of a footprint to sort of recreate that model. Now, I know everyone will go, oh, this isn't really BIM-like, it's recreating the model, but I encourage people to do this because you got to walk before you run. Before you can get to that high level of automation, you need to understand how the basics work. And so this is a good way to do that. So all I did here was trace a mass in the building, use the levels to divide the building up. And then we have this facility called perimeter core zoning, which basically divides that building up into a form that energy analysis can deal with accurately. It basically divides the building up into sort of a core and then north, south, east, west zones. It'll do it for any kind of complex geometry. It'll also apply a percentage glazing to the whole building. And that provides us with a very quick, but actually very accurate basis for energy analysis. So if you want to have a play with this, I recommend start here. Just draw a box in conceptual massing and submit that to Insight, right? The reason that's valuable is that from here, you can actually add more detail to the model. And so the next phase from here is to go into, and there's just one little thing, one of the most important things in a building energy model is actually the exterior envelope and how much glazing you have. So all I've done here now is I've literally copied the walls from my architectural model into my kind of analytical linked model, and now created the energy model from that. And now my energy model doesn't just have like 40% glazing all the way around it. It's got an actual window by window takeoff for the analytical model. So it's a very, very accurate analytical takeoff of the physical model. And then finally, you can do, sorry, I keep pressing the wrong button. Oh, this is for the MEP guys out there. The sort of MEP guys typically work with this notion of kind of zoning, where they don't need space by space zoning. They just need sort of like loads based on a subdivision of the building. So this is, again, this is third step, one level of detail further that you can go to. Very, very simple again, where we're just adding in some interior walls to provide some interior zoning. Note, I'm not doing a space by space takeoff yet. I'm just doing broad brush thermal zoning, all in the context of the architectural model. Again, you guys will know, anyone using any third-party tool, they might be using some sort of export-import thing, but they're in a completely different model, and it's hard to know if that model actually reflects the actual building. Whereas Revit has the elements in it now, we call them analytical spaces and analytical surfaces, where you can actually see that geometry and the basis of design. And if you learn how to do this much, you'll actually be able to do the sort of like the final thing, which is, here is a very, very detailed model. It's small just so that you can see what's happening. This is a full you know, DD level architectural model with curtain walls and ceilings and all kinds of stuff going on in it. And you'll see in here what I'm doing is, notice up to now we haven't had to add any rooms or spaces to do the analysis because they're not actually necessary to create the model. In the past, you had to add those things, and that's where the old GBXML export all went wrong. Here, what you can do is you can basically just place spaces for the primary reason of just differentiating what's happening inside the building. So if one room is a meeting room and the other room is an office and the other room is circulation, and they've got different sort of occupancy profiles and things that affect the building energy, you can use spaces to define those differences, right? So the key thing here is that we don't just have a single way to build an energy model from Revit. We actually have multiple ways that scale from very, very early conceptual massing to very, very detailed space by space modeling. So it really spans the whole process, and it's all fully automated. You're not really creating an analytical, you're not authoring an analytical model, you're just setting architectural elements to be used for the creation of those spaces, and that all gets wrapped into things. So that's basically the geometry side of things. Once you've got that geometry, when you go into, if you want to analyze it, just go to Analyze and click on Generate. You'll see it under the Energy Optimization panel. You see this Generate Insight. What that will actually do is that will send whatever analytical model you've created to the cloud and run actually a few hundred simulations on that model. And what it does then is that the actual Insight sort of website looks like this. So while you need Revit to generate the analytical model and generate the analysis, the actual results are all viewed and interacted with through a web browser. So the results can be shared and people can kind of collaborate on it. But it's intended to be super simple, right? And that's a great strength. The only weakness is that it'll only go so far in the level of detail that you want to, but it's still very, very complete, right? But the key thing to notice about it is that it provides this sort of single metric to focus on. So for example, you can work in what we call energy use intensity. That's basically things like kilowatt hours per meter squared per year of the building. Or if you want to put it in more meaningful human terms, you can put it in cost, right? So this is 21, in this case, dollars, I can set it to pounds, 40 per meter squared per year of energy cost, right? So, but what you see here basically with Insight, the way it works is, and I'm just going to reset the way, if you run it for the first time, this catches people out because they're not clear on the paradigm. Remember, we didn't just run a single analysis, we actually run a few hundred, and we have a way to kind of scale and interpolate between all those 100 points. And so, and it's very, very accurate. It actually emulates like we ran about 1 billion simulations, right? And so what it does is it provides a range. So purely by building the geometry, setting the building location, when we send it to Insight, Insight will then show us an energy range. And the mean right now is 273, right? The minimum that it could get to is 74, and the maximum is 978. In other words, the best of everything, best glazing, best mechanical systems, lowest internal loads will give you that level of energy use. The worst of everything will give you that. And so what this now does is allows you to go through all these different factors, there's 24 in total, and really see their overall sensitivity, right? So for example, a really simple one that a lot of people like to look at early on is building orientation. If I click on building orientation and open, you'll see that this building is not sensitive to building orientation at all. The reason is it's a rectangular box, pretty much with the same amount of glass all the way around. So no matter what way you rotate that building, it really won't have much impact on building energy, right? If that building was shaped differently, this would have some shape, right? If I look at other factors, like a good one, again, to get your head around what it does is take, for example, the wall construction properties, like the U values, the thermal properties of the walls, right? If I flip this one over, you'll see this one does have an impact. And the little triangle here is basically what's in my Revit model. Now, a lot of people think in order to run this analysis, I have to set all this data that I may or may not know or even understand. But the beauty of Insight is that that actually doesn't matter because we've analyzed a range of things anyway. And so here you can see at the widest extreme, if those walls were basically just brick and no insulation, you'd see the energy would go up quite significantly to 317. If it was very, very highly insulated, like passive house level, you'll see it'll bring it down to like 252. So a very significant chunk due to wall insulation. So this is actually showing the sensitivity of the total building energy to exterior wall insulation, basically the thermal properties. And what's nice about it is that I don't have to just work in specifics. I can actually work in a range, and we positively encourage you to think this way because there's a lot of artificial precision in these types of analysis tools. Like, for example, you don't really know exactly what the weather will be or the level of occupancy, yet all these things all drive the total building energy. So Insight allows you to work with a range. Like, you could say, you know what, I don't know at all, and so that's going to effectively be a mean of that entire range. Or I could say, you know what, if this was an old school or office, I would say it's probably in the low insulated range. If it's a new sort of code compliant building in the UK, it'd probably be around there. If it was very, very high performing, it'd be around here. But what you can see here is that this is clearly showing you the point of diminishing returns, where from here on in, 260, 254, 252, it's almost an immeasurable difference, right? So we're past the law of diminishing returns. And so you can kind of imagine what Insight does is that you've got all these plates spinning at once, right? Like wall insulation, amount of glazing, amount of shading, orientation, internal loads, all the things that ultimately drive that overall outcome, and allows you to sort of move them into the sort of the right space. So you can go through and you can set up what we call a scenario. Once you set them a certain way, you just click this thing to create a scenario, and it will set that for you. So for example, I could click to mid-range and everything will go sort of into the middle, and you'll see, okay, that gets us closer into the middle of that range. Or for example, I could have like a very, very high performance range, right? And you see this is getting closer to a green benchmark, right? So green is basically above in this case here, there's a few things in Insight. Some of the complaints we get from people outside the US is that they say this is US centric. And it is in kind of some of the references that we've used, but from a building physics perspective, from a building energy perspective, it's actually just globally applicable. And just think of these things as benchmarks. Like I sort of said, when we said earlier on the energy is 273, well, is that good or is that bad? At least the ASHRAE baseline and the Architecture 2030 provide some reference as to where you are in a potential realm of possibilities, right? Now, we've had lots of feedback that people would like to be able to customize these sort of settings and so on. That's something that we're working on. But for the moment, what Insight does is it does this sort of one-size-fits-all kind of globally applicable range of sensitivities across all factors and helps you understand. So there's some really cool stuff in here around things like, for example, window-to-wall ratio. Like if we greatly increase the window-to-wall ratio, you'll see that the glazing properties become a lot more sensitive. And yet if we reduce the glazing properties to a much worse case glass, you'll see now all of a sudden the amount of glass becomes more important. So it's basically computed any possible combination of those key design factors. And if you think about what that would take to do manually, you'd have to build a base model, create one model that has 40% glass, one model that has the shading, and then another one that has both, and then you have to run all three in parallel and then extract the results and do some sort of manual comparison. Insight is really doing that automation of optioneering and range-based analysis that really allows you to do that sort of side-by-side comparison of a range. Does that make sense? So to finish up, I'll show you what happens on the systems analysis side of things. So everything, I'll just go back to PowerPoint for a minute. So everything you need to do here with system analysis is really already done. For Insight, you set the building location. You create your building geometry at any level of detail. From here, you can run Insight and explore that whole range of performance and get a pretty accurate overall building energy target and sensitivity. The optional additional steps, of course, in Revit, you can add material building thermal properties. A lot of people aren't aware of this, but you can add conductivity, density, specific capacity of insulation and brick and concrete, just like you can in any other third-party analysis tool, right? You can also add space-by-space properties like occupancy, lighting, and equipment. All of this information is fundamental for mechanical HVAC system sizing, as well as whole building energy analysis. And so once those things are done, the optional additional steps, you can go straight in and run a systems analysis, and it will provide what we call an ideal loads calculation. In other words, it will just tell you how much heating and cooling each individual space needs, the maximum, and then the total for the building. But it won't account for the amount of energy it takes to deliver that heating and cooling to the building because you haven't defined the mechanical system. So to define the mechanical system, all you need to do is essentially, you use these little things we call system zones, which basically mark up regions of the building. You can just draw a line through a few spaces or draw a ring around it. What it's trying to do is a kind of a BIM-based version of what an engineer normally does with a red line. And to that, you attach zone equipment, right? So that's things like fan coils, VAVs, VRF, you know, underfloor air, whatever it might be. packaged thermal air conditioners. And then to that, you can attach central plant. So you can set up that strategy. And then this gives you this sort of three-dimensional schematic of the building, as well as the total building energy analysis results, plus the size of all your heating and cooling equipment, as well as all of the loads in the spaces. So here you'll see that little blue looking model. The bits that are red, each one of those is a zone in a building where, you know, for example, if I can, depending on where, if we're at the same speed, you're seeing like this is a zoned VAV system. You've got north, south, east, west, and each one of those will have a load on each space as well as a load overall on there. In other words, one air handler serves each of those apart from the void spaces. But one air handler is serving each of those voids, and each of those spaces have individual zone equipment in there. So that's how the systems analysis works. And to look under the hood, because it's powered by Energy Plus and Open Studio, Energy Plus itself is unquestionably now the world's de facto standard for this tool. You know, where we're using it, but before we were using it, Train Trace are using it, Carrier Happy using it. Again, I know they're US centric, but they do work globally. Design Builder in the UK uses Energy Plus. The key difference is that Open Studio is basically a series of APIs for creating Energy Plus models. And so if you look at this little segment of code here, this is essentially setting the properties for, I think it's a packaged terminal air conditioner. So if an engineer wants to know how the analysis is actually being run and the performance properties that are set, they don't have to bog Revit down with a Revit family or any obscure parameters. They can actually go into the code, create that particular bit of data for themselves, and then create their own sort of custom analysis. And what this really opens up is the opportunity to now finally connect not only the architecture and the analytical model to the analysis, but the analysis to the physical model. Because like I said earlier on, you know, when you do this analysis and you've sized all your air handlers and boilers and chillers, you now have valuable information and even the topology, the system schematic to use to drive everything downstream. And so we've already seen people do these things with Dynamo where they can read out the list of equipment, automatically populate the model with the equipment, and then connect it to the sizing and things like that. So there's a whole raft of workflows that this opens up. We're trying to, we're really, the way I describe it, we provide like a vanilla end-to-end workflow for whole building energy or system sizing, on top of which you can add your own level of customization. So it really means that for anything an engineer wants to do, they can do it. It also opens up the opportunity for equipment manufacturers to be able to, and not just for mechanical, but also for insulation manufacturers or anything like that, or even some exotic stuff like dynamic glass. If you want to establish the amount of energy savings through dynamic glazing, you know, like electrochromic glass, that's a complex thing to simulate, whereas Energy Plus can do that, and you can write a line into the scripts to actually turn your glass into electrochromic glass and see the overall impacts, not only on energy, but on building load. So our goal with this is not just to provide an analysis feature. At its most basic, it's that, but it's also a framework that, you know, Revit itself, you know, is a platform, and this is basically a platform for doing this type of analysis. So I'm going to stop there and see, yeah, just to give you one more little thing for MEP engineer on the call. So this is the system zones. They connect to zone equipment connects to air systems connect to water loops. And, you know, again, that's a little bit American speak. That's like VAVs and then air handlers and then boilers and chillers is the way to kind of describe it. And then, of course, you can add custom parameters to Revit. You can use physical mechanical equipment and have parameters in them, write them back and forth, and then that's what's used to create that analytical model. So I see a question there, can it be used for passive house planning packages? So no, so the passive house has a particular spreadsheet calculation that you've got to define all that data in, right? You could, of course, run a whole building. So the thing to remember with passive house, it's kind of like a rating system where it's requiring you to gather all your inputs. It does a calculation and check if you're in compliance. It tries to provide you with a picture of likely building energy, but it's not really that accurate or realistic. It's indicative, right? And it's sensitive to any changes that you make. You could, of course, take that same information, define that in Revit, run a whole building energy simulation, and that will get you closer to what the building's actual energy use will be, as well as accounting for things like ranges of occupancy. I mean, I always like to show this example in Insight where, you know, a lot of energy modelers assume that they know the operating schedule of a building like it's a fact, but in fact you don't. If you're building a speculative office building, it could be anything from 9 to 5, Monday to Friday, to 24/7. So in that case there, you would the right assumption would not be a single point of performance, any one of these. It would actually be something more like the entire range. And this range-based approach fundamentally improves the accuracy of the overall building energy model, because you're not pretending to know something that you don't really know. So no, it doesn't really do the passive house documentation, but it would allow you to simulate a passive house system and building. And then there's another question about what features would you recommend for architects in the early Revit stages? Yeah, so what I showed early on is I would recommend you start with conceptual massing and insight. You'll get a tremendous amount of value. A lot of people think that because this model here on the right is very simplistic in geometric terms, it can't be that accurate. That's a really good example of confusing accuracy and precision. The thing that really drives building energy is the building shape and its sort of orientation, and how much glass you have on the building where. Anything beyond that, you're getting into finer and finer details, and those details matter when you're making that precise decision. But if you start early on to understand for your location, your climate, and for your building form, your massing and the footprint of it overall, and broadly where you're putting your glass, then it'll help guide you into the sensitivity and the impact of glazing properties and things like that. And again, I'll show you this in this particular template here. There's already a lot of walls. This is available in that link to the AU class, and it is in metric. I did it at the time to kind of prove this point that this stuff is not US centric, right? Solely US centric. There's a whole bunch of families in here: brick, block, wall, metal, timber, below ground, whatever, with different levels of thermal mass, different insulation. They're really just intended to be indicative of what you can do. But what you'll see, of course, if I click on any of these, is that they have all of the material thermal properties set up in them layer by layer. You've got all of the insulation, blah, 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 you know, all that stuff that goes in there, and giving you your overall U value and things like that, as well as, again, a lot of people don't know this, for the glazing, I've got, again, just a broad range of glass from high, medium, and low thermal and solar performance. So it just gets you the ability to see that, you know, you can model windows and curtain walls and systems, and you can embed very easily. You can see that's a very thick wall for the passive house sort of thing, right? If you look at this window property here, you'll see it's got this, what we call schematic type. I can create my own custom ones if I want. If I want to override that and say, you know what, it's got a visible light transmittance of X and a U value of Y and a solar heat, I can define that, and that will get used in the analysis. And of course, whatever I model here in Revit is what will show me if I was to look at the glazing properties factor, and I had very high performance. That's actually what that glass is there. You see, it's right on the lowest end of that spectrum, the highest performing glass. It's one of the higher performing ones. So this shows you your sensitivity. That's single glass. That's our sort of triple low E glass. And you can sort of see there's a and that's just the south facade, right? So that's a very significant on total building energy for the glazing. So I would suggest that's where you start. And that will really take you through not just conceptual, but schematic stages as well. Beyond that, to be fair, the architect doesn't have a whole lot more left to do. It starts to rely more on the engineer and the decisions they'll make about the type of equipment. But it'll allow you to start to prompt the engineer to ask these questions early on. And you speak to any engineer, they want to get involved more early in the process to guide those decisions. It's just that the traditional tools for doing this type of analysis are usually very cumbersome and expensive. So they reserve this type of analysis to later on. So that's where we're in this catch-22 right now with a lot of these tools.
Well, thank you very much, Ian. It's nice to have some M&E for a change. And now I'm going to hand back to Matthew, who is doing another poll.